Okay, so our goal is to find the length of the cable, and we're told that the cable hangs between two towers that are 200 feet apart, and for the equation that describes the shape of the cable is y equals 150 times cosh of x over 150. So I do want to point out quickly here that cosh, sinh, and hyperbolic tan are hyperbolic functions, right? So cosh of x, and I've included a link under this video on the Canvas webpage that has a cute little video that introduces or it kind of explains the hyperbolic trigonometric functions. So if you're not that familiar with cosh and sinh, you didn't work with them in your first calculus course, go ahead and check out the link. Watch the videos. Google, find some other YouTube videos that get you that kind of show you the properties and get you familiar with working with the hyperbolic trig functions. This is especially important if you are interested in engineering, because the hyperbolic trig functions show up a lot in engineering, and you want to familiarize yourself with them just like you would, cosine and sine. Okay, so first thing I kind of want to do here, I'm going to draw a little picture, and here's my picture. So imagine I've got these, maybe some two towers here. Okay, and between the towers is hanging a thick rope. So let me make kind of a thick rope here. So this kind of gives us a picture of the cable, and we're saying that y equals 150 cosh of x over 150 is describing this shape here, this shape right here, okay? And the fact that our towers are 200 feet apart means from here to here is 200 feet. We can put that in the picture, 200 feet. Okay, and our goal is to find the length of the rope. So we want to go to our familiar formulas. We've got our formula. If we are given a function, y in terms of, if we're given y equals f of x, and we want to find the arc length of that curve between a and b, then this is the formula that we use. Okay, so let's see here. So I've been given my formula for my f of x. So f of x is going to equal 150 times cosh of x over 150. So that was given to us in the problem. Okay, and then what about a and b? Now we're told that a and b are let's say we're told that the towers are 200 feet apart. So here's what's reasonable. What's reasonable would be to have an axis like this, right? So in this case, we'd have 100 and negative 100. So we'd have negative 100 and 100. So imagine this is the x-axis and this is the y-axis. Okay, so we can let x vary between 100 and negative 100. So a is negative 100, b then can be 100. Okay, and now what remains is finding the formula, or evaluating the formula for the arc length. So let's go ahead and get started with that. So L is going to equal the integral from negative 100 to 100, the square root of 1 plus. Now, in order to do our formula, we need to know the derivative of f, and then we need to square it. So, if f of x is equal to 150 cosh of x over 150, then f prime of x is going to be 150 times the derivative of cosh of x over 150. Now, to get this, to find this derivative, I'm going to use the chain rule. And I need to remember that the derivative of cosh is sinh. So I'll have sinh of x over 150 times 1 over 150, because that is the derivative of my inside. So I'm using the chain rule here. So I'm using the chain rule plus the fact that the derivative of cosh is sinh. Cosh of x is sinh of x. Okay, so we will have, when we multiply this out, the 150 and the 1 over 150 will cancel out, and our derivative is just going to be sinh of x over 150. Okay, so here we'll have sinh of x over 150, and this will be squared dx. All right, so we'll have the integral from negative 100 to 100, 1 plus sinh squared x over 150, and the square root of that dx. Now, I kind of smile because I know another property of hyperbolic trig functions. So I know that just like sine squared of x plus cosine squared of x is equal to 1, cosh squared of x minus sinh squared of x is equal to 1. So these are properties. This is a property of hyperbolic trig functions. So I can use that to say that 1 plus sinh, so let's see here, 1 plus sinh squared of x is equal to cosh squared x. So in this square root here, I'll have the square root of cosh squared x over 150, but that's just going to leave me with cosh of x over 150 dx, 100 to 100. Okay, so I can do a Usubstitution. So let me just kind of move to the side here. So the integral of cosh of x over 150 dx is equal to, so let me do a Usubstitution. I'll let u equal x over 150. Then du is equal to 1 over 150 dx. So I can rewrite this as 150 times the integral of cosh of u du.
It's 1445.
So dx is 150. Yeah, I did that right. Dx is 150 du. Okay. And the integral of cosh I know to be equal to sinh of u, which is going to be 150 times sinh of x over 150. So again, that's one of the properties, is the derivative of cosh is sinh, and the derivative of sinh, let me try to make this bigger. So the derivative of cosh, right, the derivative of cosh is sinh, and the derivative of sinh is cosh. So why do we care about that? Well, we care about it because when we go to integrate cosh, what is the antiderivative of cosh of u? It's going to be sinh of u. Okay. And we can in fact put plus c. So now we can use the fact that the antiderivative of cosh of x over 150 is 150, that should be sinh of x over 150 plus c, to now we can evaluate this definite integral. So this is going to be equal to 150 sinh x over 150 evaluated at x equals negative 100, x equals 100. Okay, and this is going to be equal to, So this is going to be equal to 150 sinh 100 over 150 minus sinh negative 100 over 150. Okay, so we'll have sinh of, was that 10 over 15, which is 2 over 3, sinh of 2/3 minus sinh of negative 2/3, and all of that times 150. Okay, so this is going to be e to the 2/3 minus e to the negative 2/3 over 2 minus e to the negative 2/3 minus e to the negative 2/3 over 2. All of this times 150. Okay, now some stuff should cancel out. So we'll have e to the 2/3 minus e to the negative 2/3 minus e to the negative 2/3, that's minus 2. And then minus negative is going to be plus, so that'll be 2. And then all of this is over 2. Okay. And the 2's cancel out. Okay, so we have 150 e to the 2/3 minus e to the negative 2/3, which we can write this as when we plug it into the calculator, we should get approximately 215 feet. Okay, so looking here, if this is the equation that describes the curve, that Caternary, right, if that's the equation for the shape of this curve right here, and the towers are spaced 200 feet apart, then the length of this rope or this coil is approximately 215 feet.